In this lesson, we're going to take a look at levers and mechanical advantage. Let's diagram the key points of a lever. So right here in the middle, we've got the fulcrum, and that's the pivot point of the lever itself. And at one point, I'm generally going to mark it in red. We're going to have a weight, and we're going to call this the force of resistance, or we're going to label it FR. And this can be in pounds or newtons or kilograms. This is just a force of resistance. This is essentially a static weight that is not human applied. On the opposite side of this lever, we're going to have kind of a human applied force, and we're going to call this the force of effort. So force of effort, or notated FE. Again, could be pounds, could be kilograms, any of that. We also are going to note the distance from the pivot point for each of these. So from on the red side here, this is the distance of resistance, and it's measured from center of mass of the force to the fulcrum. Same thing for the effort side, from the center of mass to the fulcrum. This is the distance of effort, so noted DE. So we get a lot of letters, DE, DR, FE, FR, but it's just really an abbreviation for the distance and the force. We talked about this previously, but we have two mechanical advantages. We have the ideal mechanical advantage, and that one, the formula is going to be IMA is equal to dE over dR. And then the AMA, or the actual mechanical advantage, that's going to be equal to AMA is equal to FR over FE, where force of resistance or force of effort. Now, the thing to notice here is that the ideal mechanical advantage is just a ratio of distances, while the actual mechanical advantage is a ratio of forces. And this is key. So I've come up with a quick little mnemonic device or memory device here to remember which one's which. IMA, or IMA, I like to say, I'm a deer, am free. I'm a deer, am free. So I've got my little Rudolph over here, and he's representing IMA, and obviously my janky American flag here representing freedom. The configuration of a first-class lever allows us to have the fulcrum in the middle, and it's balanced by two forces on each other side. These distances between the forces in the fulcrum could change, and would change the mechanical advantage to be either greater than or less than 1, but the fulcrum will always remain in the center. In a second-class lever, we're going to have the fulcrum at one end, and then we're going to have the effort force on the opposite end from the fulcrum, all the way at the end. And then somewhere in between, we will have the force of resistance. So once again, our distances are going to be measured from the fulcrum to like the center of mass of the force of resistance, and then to the center of mass of the distance of effort. And you can see here, if we reflect back on our IMA equation, dE over dR, that in this case, our distance of effort is always going to be greater than our distance of resistance, and that means that our IMA in a second-class lever has to be greater than 1. The third-class lever is a lot like the first or second-class lever. It looks pretty similar, except in this one, the fulcrum's at one end, the force of resistance is at the other end, and the force of effort is in the middle. Once again, the distances are just measured from the fulcrum to the mass, so our distance of effort is here, and our distance of resistance is here. If we look at the IMA equation again, dE over dr, we'll notice that in the third class lever, dr is always going to be greater than dE, and in that scenario, the IMA, it has to be less than 1 because dr is greater than dE. So I have a quick mnemonic device here for remembering the three levers. I've drawn them out as listed. And if we note what's in the middle, here in the first class lever, we have the fulcrum in the middle. So 1, F. If we have the second class lever, what's in the middle? That's our resistance. So 2, R. And if we look at our third class lever, what's in the middle? That's our effort force, so 3, free. So my mnemonic device is 1, 2, 3, free. 1, 2, 3, free. You should be able to remember them. Now, also note that in our mechanical advantages, we can change the configuration of a first class lever to make it greater than or equal to or less than or equal to 1. In our second class lever, as we discussed in the previous slide here, it has to be greater than 1 because the dE is always going to be greater than dr. And the third class lever, we're always going to be mechanical advantage of less than 1 because dr is greater than dE.